All right. So we have been looking at the final two class periods on factoring. And then now we're going to look at a method called AC method. Okay. The AC method. Now, in a quadratic, takes the form, okay, actually without the equal sign. This is a quadratic right here. In this particular case, you're dealing with three terms. So this is a trinomial, and the degree is 2, and that's what's making it a quadratic. Okay. And last time we looked at if our leading coefficient here is 1, we worked through a method on how we could derive that number being factored, or that expression being factored. So here, for the AC method, what we're going to do is we're going to multiply the A times the C. Okay, and that's going to give us a number. A times C. And what we're going to do is we're going to find two numbers that, when multiplied, give us that AC. But those same two numbers, when they are added together, they give us the middle, the coefficient of the middle term, B. Okay. Once we find those two numbers, just for, let's see, we can use the letters D and E. Then what we do is we split this middle term into D and E, because remember, D plus E is equal to B. So we're going to split B into D and E. So what you end up getting is AX squared plus DX plus EX plus C. Okay, and what we've done here is this DX plus EX, if we were to add that back together, that would equal BX right there. So we haven't changed anything. And specifically the D and the E, they add together to give me B. But when they multiply together, they give me the same number as if I multiplied A and C. Okay. And we'll work several examples just to try to keep that all straight. All right. Then what we do was we group them. And we group them with parentheses. Sorry, AX squared plus DX, parenthesis, plus EX plus C. Okay. All right, now from here, I can't use letters anymore because it'll depend on the specific numbers. But essentially, we factor out common factors. Here, we factor out common factors here. And what you'll notice is that you're left with equivalent bracketed expressions. And you'll have some sort of coefficient out here of things that were common that you took out. And same thing here. You'll have some sort of common thing that was taken out. Okay, we'll make that a triangle. So then, since these two are the same, those also can come out. And that identical expression here is a common factor between these two terms. Here's that plus sign. And it comes out, and what you're left with is triangle plus circle. And it's factored. Now, I'll let you copy that down. It can be, looks a little crazy there, but this is, once we do an example or two, this will make a lot more sense. So go ahead and keep that in your notes, and then we will work a few equations. So give me just a second here. I should have had this up earlier, but I did not. To make sure. We've got some good examples to work with. All right. Okay. So let's start with 3p squared plus 13p minus 10. All right. 3p squared plus 13p minus 10. So the first thing we're going to do is kind of identify, what are our A, B, and C? Because remember, the proper quadratic is ax squared plus bx plus c. Now, in this case, obviously, we're using the variable of p, and that's okay. That doesn't change anything. So my a, that would be 3. My b, that would be 13. And my c, that would be negative 10, right? I can just as easily change this to a plus if I make that a negative, plus a negative 10. So negative 10 is my coefficient. All right, so remember the first thing that we're doing is we're doing a times c. So a times c is going to be 3 times negative 10. And that's going to give us negative 30. All right, now what we're looking at is two numbers that multiply to give me negative 30. Those same two numbers I add, and they'll give me the middle term of 13. All right. And so we can see that 10 and 3, if I had 10 and 3, it gives me positive 13, but but if I multiply 10 and 3, that gives me positive 30. So let me go ahead and break 30 down. Obviously, that's 15 and 2, 5 and 3. Okay. So 3 and 10. You can also do 6 and 5. 15 and 2. Positive 30. Oh, 15 and 2. That's what it could be. 15 and 2. If I have a positive 15 and a negative 2, that would give me a positive 13. Then if I did a positive 15 times a negative 2, that would give me negative 30. Okay. Okay. So now that I have my numbers, 15 and negative 2, I'm going to rewrite the original, except this middle term, we're going to split into 15 and negative 2. So I'm going to do 3p squared plus, And instead of 13p, I'm going to do 15p. And I'm going to go ahead and write plus here, even though this is a negative, and do a negative 2p. That's going to help me keep everything straight until the end. And then plus a negative 10. Okay. I just think you don't have to do it this way, but the negative signs is usually where people make mistakes, and this is a good way to do that or to prevent that from happening. Okay. So here you have 3p squared, negative 10. That 13p is split into 15 and negative 2. Okay, so now I'm going to add parentheses to the first two terms and the last two terms, okay? So now, now that I've added the parentheses, I want to pull out common factors. So here we can clearly see there's a p. So I'll go ahead and get a p out. Then 13 and 3, they both share a 3. So I can pull a 3 out. And so if I pull out a 3p from 3p squared, I'm simply left with p. And if I pull out a 3p from 15p, then I'm left with 5. So 3p times p gives me 3p squared. 3p times 5 gives me 15p. Now I will add, here I have two negative numbers, so I can pull out a negative. I can pull out a 2 and a 2, and this will go down to a 5. So I can pull out a negative 2, but that's really it. Then I'm left with a p plus 5. All right. So this was kind of when I started showing shapes of things. We pulled out, okay, and then we pulled out something out of the first group and we pulled out something out of the second group. And then what we noticed is what's in parentheses is actually going to be identical. And that's what we see here, that what's in parentheses is actually identical. And so what we can do then, because these are factors, I can pull those factors out. These two terms split by this plus sign, okay? I'm multiplying a 3, a p, and a p plus 5. And then over here, I'm multiplying a negative 2 and a p plus 5. But you see, the p plus 5 is being multiplied by something in both terms. So I can pull out the p plus 5. That is the common factor, okay? Pull in the p plus 5 out. So then what's left in this first term here, if I pull out the p plus 5, I have 3p left. And then here, if I pull out the p plus 5, I have the negative 2 left. And that is your answer. P plus 5 times the quantity, 3p minus 2. Right. Let's do another example. Right, I'm going to do 5x squared minus 58x plus 80. All right. Okay. So one of the first things to always check, and I didn't mention this on the last time, but one of the first things to always check is to see, hey, do I actually have a common factor in each one of these terms? So here I have a 5 and x and a squared. I've got an x here, but no x there. I have a 5 that I could pull out of here and here, but I can't pull it out of here. These two are even, so I know I could at least pull out a 2, but I can't pull a 2 out of there. So no common factors to pull out. That would be the first thing to check. Okay. Since this coefficient is not 1, I can't use the normal two things that multiply to give me 80 that add to give me negative 58. So I'm going to use the AC method. So let me just write that off here to the side. My A, my B, and my C. My A is 5, B is negative 58, and C is positive 80. All right, now my AC is 5 times 80. 5 times 80 is 400. 5 times 8 is 40, and then I have the extra 0, 400. All right, so I am looking for two numbers that multiply to give me 80. I'm sorry, 400. What am I saying? 400. There we go. And those same two numbers need to add to B, which would be negative 58. All right, so this one might be, I'm going to do this one or the actual factoring on a different sheet of paper. So that we can keep kind of the factoring part here together. So let's just factor 400 and see what we get. And we're going to look for two numbers that also add to give me negative 58. All right, so 400 can just be 200 times 2, 100 times 2, 50 times 2, 25 times 2, and this is obviously 5 times 5. So 2 5s and 4 2s gives me 400. All right. So what numbers does this give me? Well, 5 and 10 times 2 is 20, times 2 is 40, times 2 is 80. Obviously, because that's what we had before. So 5 and 80. 25 and 4 times 4 is 16. Would that get me close to there? Let's see, 6, 7, 8, 9, 10. I don't think so. 25 plus 16. Nah, that would give me 41. Not close. Okay. Then we can do 25 times 2. 25 times 2, that would give me 50. And then I'd have 3/8. 2 times 2 times 2 is 8. So 50 and 8 I know can work. So negative 50 plus negative 8 would give me negative 58. And if I multiply negative 50 times negative 8, that would give me 400. All right. So we've got something, negative 50 and negative 8. Negative 50, negative 8, negative 50, whoops, negative 8. All right. So let's continue here. So we're going to rewrite the quadratic, splitting that negative 58 into our two new numbers here. 5x squared plus a negative 50x, and notice I'm using the plus a negative, plus a negative 8x plus 80. All right, next thing we do is we add the parentheses. We're going to add them around the first two terms, keep the plus sign in the middle. And we're going to keep that negative there with the 8. See, if I would have made this 5x squared minus 50x minus 8x, then I would have had to have realized that this would have had to have been negative because I'd be multiplying the negative in. It's one more step, complication that I don't think is necessary at this point. All right, so here I can take out a 5 and an x. Leaves me with just an x there. And this will be plus negative. And if I take a 5 out of the 50, that gives me 10 and an x, so the x goes away. All right, then plus. Then here, now this is negative, but this is not. So I'll go ahead and take a negative out, negative 8. The x will be left. And then plus 80. So if I take an 8, negative 8 out of 80, then I'm left with a negative 10. The negative 8 times 8 is negative 8. I'm sorry, negative 8 times x is negative 8x. And a negative 8 times negative 10 gives me a positive 80. All right. And we can see that what's inside our parentheses is identical. So I can pull it out as one factor, x plus negative 10. And then what I'm left with, since I pulled it out of this, I'm left with 5x plus negative 8. Because this and this have been pulled out. So the 5x plus negative 8 is what's left. All right, now I'm going to write that normally. This is going to be x minus 10 times 5x minus 8. And of course, we can check it. X times 5x, 5x squared, x times negative 8, negative 8x. Negative 10 times 5x is negative 50x. And negative 10 times negative 8 is positive 80. And then these two would combine to give you negative 58. All right. Let's go ahead and work another example. All right, let's do 30x squared minus 72x minus 54. Okay. Now, remember, the first thing that we want to check is to see if there are like terms in the original trinomial. Okay, we're specifically looking at trinomials, specifically quadratics in terms of factoring. So I've got a 0, a 2, and a 4, which tells me I can at least take a 2 out. I wonder if I can take a 3 out. Let me do some math on a piece of paper over here. Let's see if I can take a 3 out of the 72. I'm trying to remember. 6. Yeah. 24. 24 times 3 is 12. Okay, so I know I could take a 3 out. I wonder if I could do more. Well, let me do this. 30, 5 and 6, 2, 3, 72, 3 and 24. 24 is 12 and 2. 12 is 6 and 2. And 6 is 3 and 2. And 54. 54 divided by 2. Let's see, 21, 26, 27. And then 27 divided by 3 is 9. And then 9 obviously is 3 and 3. 3 and 2. Okay, so they each have a 2. They each have a 3. Do they each have more than one 3? These two have more than one 3, but not this one. About 5. Nope. All right, so a 2 and a 3, which means a 6. 2 times 3. Okay, so I can actually pull a 6 out of this. That's good news. It'll make my number smaller. So if I pull a 6 out, 6 times 5 is 30. So that becomes 5x squared minus, and then the 72, if I take a 6 out of that, that is... So, well, 6 times 10 is 6. There's going to be more than 6 times 12. I think it's 6 times 12. 6 times 2 is 12. Yeah. Okay, so that gives me negative 12x. And then 6 times what is 54? I think that's 6 times 9. Yeah, 6 times 9. So minus 9. All right. So a little bit easier numbers there to deal with. Obviously, I don't have a 1 here. So I can't do the two numbers that multiply to give me negative 9, add to give me negative 12. I have to use the AC method. So as I factor this, and I want you guys to remember this, I'm going to keep this 6 here on the side because the factoring occurs inside the parentheses. We're going to end up with something like this. Okay. We factored the 6 out, and then we've taken this and we factored it into two binomials. Binomial meaning two terms. Okay. All right. Now, let's go back here, looking at just our quadratic. After I factored the 6 out, my A is 5. My B is negative 12. My C is negative 9, which makes AC 5 times negative 9, which is negative 45. Okay. I want two numbers that multiply to give me negative 45 that also add to give me the middle term, which is going to be negative 12. All right. So all the numbers that multiply to give me 45. Well, we obviously know 9 and 5. And 9, of course, is 2 3s. So 15 and 3 is, that's close to 12. 15 and 3. So if I had a positive 3 and negative 15, that would give me negative 12. Positive 3, and I add that to a negative 15, that would give me negative 12. And 3 times 15, that's going to give me 45. So negative 15 times positive 3 is going to give me negative 45. All right. So a positive 3 and a negative 15. Those are going to be my numbers to work with. So like I said, I'm going to start with the 6. And then inside, I'm going to have 5x squared. And then I'm going to have plus 3x. Then I'm going to have plus negative 15x. These two numbers add to give me my negative 12. And then minus 9. All right. So now what I'm going to do is put in parentheses. Now there's already parentheses here. We want to make sure we keep our parentheses straight. So we have the parentheses that's going to encapsulate the quadratic, but inside those, I'm going to add a set of parentheses around the first two terms, plus a set of parentheses around the last two terms. Now, why did I do that? Because if I didn't, Okay, this 6 would only distribute into these two and not these two. So if I have two sets of parentheses, what I'm saying is this 6 here on the outside belongs to this set right here and this set right here. Okay, which is the same thing as if I dropped those inside parentheses and I just had this 6 would go to each term on the inside. Okay, so make sure you keep those parentheses close. Now, I have 5x squared plus 3x here plus negative 15x minus 9. Let's start taking out the common factors. So out of here, I don't have a common factor of 5 and 3, but I do have at least one x. I'm taking one x out, and I'm left with 5x. Then here, plus, took the x out, that's 3. Then plus, then here I've got negative 15 and negative 9, and they share a negative 3. So I'm going to pull out a negative 3. And a negative 3 out of the 15 gives me a positive 5. I have an x, negative 3 out of the negative 9. I'm left with a positive 3. End parenthesis, and a second parenthesis. Okay, for that x. Now, you can see that I've got identical binomials here and here. Okay. So I'm going to pull them out of these two terms. Okay. So they're going to come out here with this 6. And that's because if the 5x plus 3, if I take it and put it over here outside with this x, and I'll just show it to you because I think that's probably easier. I'll have 6, and then I'll have the 5x plus 3. And then what I'm left with here, there's a term. If I take out the 5x plus 3, I'm left with an x plus, over here, I'm left with a negative 3. Okay. So notice that if I were to take this right here, okay, just like distribution, and I were to distribute it here and here, like we would, right? Then you have 5x plus 3 times x. That's what I have right here. Then you would distribute it over the plus sign, just like over here. And you'd have negative 3 times 5x plus 3, which is what we have here. So it's just a reverse of distribution. That's factoring. We take it out, we put it right there. What's left inside is x plus negative 3. That's what's there. Okay. So then my 6 is also outside. I have 3 factors. 6. My second factor is 5x plus 3. My third factor is x plus negative 3. Now, how can they be factors if I have a plus sign? Because I have parentheses. So this has factor 1, factor 2. Well, actually, this is factor 2 because 6 is my 1. And this is my 3. Okay. So if we look at it visually, it's 3 things being multiplied together. 2 of those things are expressed as 5x plus 3 and x plus negative 3. All right, so I have someone saying, hey, I don't know you're getting the x plus negative 3. Very good question. So let me rewrite from right here. All right. Let's see if we can clear this up a little bit. All right. So I'm going to replace the 5x plus 3 with just a box. Okay. I'm going to try to simplify this visually. So we're going to have 6 times x times, and then I'm just going to replace 5x plus 3 with a box. Okay. Put in a different color. Plus a negative 3 times 5x plus 3. Okay. Okay. So if I take this blue box out, okay, let's say I do that. Let's say I take that blue box out. Then what I'm left with is 6 and the blue box times the blue box. Okay. Times, okay, because I have this. Well, what's left? Well, that x, that's left. And then plus the negative 3, that's left. This box is gone, that box is gone. It's right here. I pulled that box out, this box out. That ended up here with the 6 right in between the parenthesis and the 6. Here's my box. What I'm left with is x and plus negative 3. Did that make sense? So now we know my box is 5x plus 3. And this right here, x plus 3, we can just make x minus 3. And that's the final answer. All right. As you can tell, these are pretty involved. Um, so they'll take a little while to work out the AC method, but it works every time. It works every time on how to solve for quadratics. So all right, we'll do one that's a little bit easier, won't require the AC method, but it'll just be fun to practice factoring. So we'll do 28x squared plus 36x. All right. So here, I don't have a trinomial. I still have a quadratic. So this is a quadratic. But this is a binomial, meaning 2 terms. All right. And I can already tell that I could take an x out of each of these. So I know I can at least do that. I'm left with 28x plus 36. All right. Now, between the 28 and the 36, what can I pull out? So you could factor these numbers. 28 is going to be 14 and 2. 2 and 7 is the 14. So 2 times 7 times 2. 36 is 6 times 6. This is 3 times 2. 3 times 2. So you can see how we have 2 2's in each, which is 4. So I can factor out a 4. If I factor a 4 out of 28x, that leaves me with a 7. And if I factor a 4 out of 36, that leaves me with a 9. And I can check that real quick by multiplying that in. 4x times 7x is 28x squared. 4x times 9 is 36x. All right. Well, that is the AC method, and what we will not have time to jump into anything else. So that is class, and I've got Chloe, George, and Kathy's iPhone. Let me see. That is Julia. Okay. Very good. You guys have a wonderful evening.
Thank
What
you.
week will this homework be on?
This will be on homework. Second here. 10C.
Okay, thank you.
You are welcome.
Thank you.
Yep. See you, George.